Welcome to our Imagine video. Today I've been given the chance to explain to you a thing or two about the Beebo project. My name is Sam, and let's go meet the Beebo team.
Hello, my name is Max Barron.
I'm Ben Thomas.
My name is Emma Mahoney.
I am Barry Richter. I have come up with the idea for the Beebo project, and I'm also the software developer on the team. The Beebo project is meant to be a way for biomedical engineering students to have a more hands-on understanding of control loops and give them more experience with what this actually means and what are some applications that could help out people in the future with, say, an example of a robotic arm that we've created.
So now that we know what the Beebo is, how are we defining success for the team?
We will be fully functional to teach students about PID controls through a series of labs that go through different speed PID parameters to over-damp and under-damp the system.
Thanks, AJ. But what is PID gains, and why are they so important?
So PID controls, or proportional integral derivative control loops, is a method of controlling a wide variety of different mechanisms. One of the simplest examples would be like an oven. So when you set it to a certain temperature, you want it to reach the temperature accurately as quickly as possible. There's a few ways that it could do that. It could slowly ramp up and then get to the point that you want to be at. It could go overshoot and then oscillate back and forth. It could overshoot and then reach the right level. And adjusting each of the gains on the proportional, integral, and derivative part of the controller adjusts how that works.
The competition, they have only one or two actuators and can't sort of use their actuators in as much of a usable area.
The physical plan within the control loop system is essentially the applied output of the controller. So for ours, we have a robotic arm, as we are biomedical for this team. And our arm has 3 degrees of freedom to rotate around its base. It can move at the shoulder and it can move at the elbow. We have motors, DC motors controlling all 3 of those degrees of freedom. The controller can be applied to each one of these DC motors. So the way that we are expecting it to work during Imagine is we're going to have different movable items that it can lift up and place into a designated area. And its ability to accurately do that will be reflective of how well tuned the controller is.
Wow, PID seems like it's something really important. What makes our group exactly special?
Some other controls lab experiments that I've seen before are more just a DC motor based, where you're only controlling an RPM and you're just seeing that on a graph go up and down to hit the set point, whereas our project has more of a visual sort of application where you can see on the arm if it's hitting the set point well or not. So a biomedical application of this would be, say, delivering somebody with Parkinson's their food without smacking them in the face. So a lot of the other products out there cost a lot and are more sort of fine-tuned for doing specific controlled experiments, while our product is going to be more diverse.
What sets our design apart more is that we designed it so that it could be open sourced by the students, so that they could go in and control the robot both through the user interface they were creating, as well as being able to go through the actual code and make changes and understand better how everything is working on a lower level.
To summarize, the Beebo is both inexpensive, flexible, and also intuitive for students to understand. With such an ambitious project, there were a lot of concerns we actually had going into it about exactly how it was going to go. I'm going to have Emma explain how we kind of dealt with those concerns and how they turned out in the end.
Some other things that we were worried about with the project, especially when we were initially drafting up the idea, were supplier delays. So as we were ordering items, we were worried, okay, if we ordered this specific item, how long is it going to take? The way that we mitigated those are we made sure to stay on track and set reasonable deadlines for ourselves to complete various tasks. We did a pretty good job of keeping track of this. For the suppliers, one of our teammates called all of the suppliers.
With the Beebo systems integrated and the design nearly complete, we're excited to finally have the time to document all of our processes and make sure that the Beebo lab experience stays in BME for years to come.